Hi, welcome back to the channel. So in this video we are going to see what is flip-flops and what are the types of flip-flops. Okay, and we'll see some of the examples, right? So flip-flops is a binary element which is going to give you, which is going to take two inputs and two outputs, right? So if I write something like A and B, so it is going to give like something like Q and Q, right? So it's a binary element, so we can call it as a sequential element, right? Sequential element circuit. So we'll see types of flip-flops. Okay, so we'll call first one as a data flip-flop, right? So how the data flip-flop is, so it is having uh, D as an input, Q as an output, Q bar. So I will call it as D flip-flop. So here what is applied? Clock is applied. So when we are speaking about this clock, so it is having two types of clock. One is positive edge clock, if it is edge triggering, negative edge clock, right? So if it is positive edge, it is like this. If it is negative edge, if it is positive edge, it is like this. If it is negative edge, is like this, right? So here we'll be having a level triggered. We'll be having this as positive and it is level negative. So 1 and 0. So we can, when it is having like this, it is negative edge. It is falling from 1 to 0. When it is going from 0 to 1, it is positive edge, right? When it is level, if it is highest level is logic 1, this lowest level is logic 0, right? So that's what you should treat about the clock. Then after this clocks, we should know, since it is a sequential circuits, the sequential circuits we should give the timing. So that timing is given. So if here the symbol like this, so it is positive clock, right? So that is the first thing. Then we should write the truth table. How exactly the truth table of D flip-flop is. D is, and here it is Q, right? It's a data flip-flop. If D is 0, you will get 0. If D is 1, you will get 1, right? So Q output is going to be like this, right? So it is a data flip-flop. Now we'll consider SR flip-flop or RS flip-flop. RS flip-flop, how we can write this? It is about set, it is about reset flip-flop. Output is Q and Q bar. We'll call it as SR flip-flop, right? So how to draw the truth table? Truth table of that is, we'll be having S, we'll be having R, we'll be having Q, and we'll be having Q bar, right? So how to write this? When S is 0, R is 0, set is 0, reset is 0. Here we'll be calling this condition as no change. Status is no change. Nothing is going to be changed. Then if it is set is 0, this is 1, Q is 0 and this is 1. So we will call this as a reset condition. And if it is 1, S is 1, R is 0, we will call it as 1 0. So it is set condition. Then the last one is when both are 1 1, both the inputs as 1 1, at the time we will get it as I will just change this as Q and Q bar, as it is no change. So this can be written as invalid. For invalid, we will write don't care symbol or this multiplication symbol, right? When both the inputs are 0, whatever the output is there, similarly Q bar will remains. When S is 0, Q is 0. When S is 1, Q is 1. So when both are 1 1, it is invalid, right? So can't be determined, right? So can we draw the diagram of this D flip-flop? Suppose here I will be having a clock like this. I will just take these two cycles, right? So if D, so I will write something like D, like this, right? So how it is the output Q? So I will consider it as the negative edge triggering. For this negative edge triggering, I should see what is the value of D. At this D, what is the value of D? 1. when D is 1, what should be the Q? Q should be 1. So here it is up to here I will write it as 0. So at this point it is 1, so I will take it as 1. So it will go up to what? It will go up to next negative. So from here, what is the value of D? It is going to 0. So this value becomes 0. And it will go up to next. So from here it is 1, so it is like this, right? So here D and Q, it is almost same we will get, right? Because here it is called as data flip-flop, but it is delayed by some value. So it is delayed flip-flop also we will call it as, right? Now SR flip-flop, how to draw this SR flip-flop? So we will write S. Before that we will write clock. So we will take only this part. Yes, roughly we will take like this. R, like this, right? So S and R. So for the we will take now for the positive edge. At this point, what is the output? At this point, what is the output? You should see Q. So now 0, initially 0, right? So for this point, what is the value of S? 1. What is the value of R? 1. When both are 1, 1, it is invalid condition. So I will write here this as invalid condition. So you'll get some different lines if it is a software, right? Then after that, at this point it is clock 1. When it is at this point it is 1 and it is 0. When 1 and 0, it is set condition, what you will get? 1 you will get. So it will right? So similarly it will flow like the next part, right? So it is a SR flip-flop. So we are having a disadvantage in the last part of this SR flip-flop. So we will be moving to one more flip-flop, that is called as a JK flip-flop, right? So the drawback of SR flip-flop is when both the inputs are 1 1, we will get the output as invalid. So to avoid this, we will go to a flip-flop, and that flip-flop is called as JK flip-flop, right? So here we will write this as J and this as K. It is JK flip-flop and it is Q and it is Q bar. So what is the truth table? How to draw the truth table? J, K, Q, Q bar, right? So 0 0, same. First 3 rows, no change. What is the last one? That is what one more is, right? So we'll see that J, K, Q, Q bar, right? When both are 1 1. So here when it is Q is there, you should write Q bar. When Q bar is there, you should write Q. So this condition is called as toggling. Means if Q initially in the previous condition it is 0, it becomes 1. If initially it is 1, it becomes 0. So this condition is called as toggling. 1 becomes 0, 0 becomes 1. Other than the rest are same. No change. Here it is reset. Here it is set. So the modified version of this RS flip-flop is nothing but a JK flip-flop, right? So we'll see how exactly we should draw this. Now we can observe the truth table of these two, right? This and this. So here both are different, right? Except that these three are same. So quickly we can see here for this condition. Now only for this condition I will draw now. Clock is at this point when both are 1 1. What you are getting has invalid here, but here what you should get, if it is Q, Q bar you should get, right? So output, now look at this, how it is going to be changing, right? So now when both are 1 1, whatever the previous state, what is the previous state here? 0. So it is going to be retained, right? So sorry, what is the previous state? It is going to be reverse. So previous state is 0. Now it has to be toggling, right? Because here you can look at when both are 1 1. If it is Q, it should be Q bar. So if Q is 0, so Q bar should be 1. So it will go up to this stage. At this stage, it is 1, it is 1 and 0, same. 1 and 0 means it is set like this, right? So now this is toggling happened here, and here it is 1 and 0 means it is set happened here, right? So this is what waveforms with respect to JK flip-flop, right? Thank you. We'll see in the next video with the more updates.